Hi, good morning, everyone, and welcome to this HEDGE-IoT session on interoperability, semantic interoperability and standardization. Good to see you all. We will leave a few minutes for more people to join, as we have, there's many people who registered for the event. Okay, I guess you can see my screen. We're also recording the event for your information. It will be for internal purposes or to have in our website. So if somebody disagrees, please let us know. Okay, welcome everyone who's joining. I will share the agenda. Okay, I'd say one more minute and then we give it a start. Okay, so good morning, everyone, and welcome to this session organized by HEDGE-IoT. This session will focus today on semantic interoperability and standardization. Here you can see the line of speakers. So we will have both colleagues from the project explaining the work that we're doing within the scope of HEDGE-IoT, and also some external guests, so to say, external speakers that will give us an overview on current standardization activities, mainly happening in Europe. And then I'll share the agenda. So we will have this overview on standardization activities from CENELEC, also from ETSI, ETSI data. And we will also see the achievements of the HEDGE-IoT project with regards to standardization and semantic interoperability. And then at the end, we will have a roundtable with our speakers. We will see how HEDGE-IoT can contribute to standardization activities, what are the existing gaps in semantic interoperability standards, and so on. So thank you all for joining. And without further ado, I will give the floor to the first speaker, so Sebastian Steinbus from IDSA. I will let you share your screen, if that's okay.
Absolutely.
Okay, great.
So good morning also from my side. Glad to be with you today and give you an overview on standardization activities that happen on data spaces with a strong focus on European standardization, especially on the field in CENELEC JTC 25. So I have prepared some overview on what I'm going to present today. I would like to start with a general short introduction on the special relationship between European legislation and standardization activities, especially with a focus on the Data Act very briefly. And then, of course, the main topic of my presentation will be the European standards under the focus of the European Trusted Data Framework. And then I would like to connect it in the end also with some international standards and to draw some conclusions. The first slides might be a little bit boring, but it's important to know that there is a difference between what we have in regulations and what we have in standards. While following regulations and the law in general is a mandatory thing, following standards is voluntarily. It's an optional thing to follow a standard and to implement a standard. Regulations are created by the policymakers, by our governments, our local governments, regional governments, and the European Commission. The creation of standards is done by private and independent organizations. And especially in Europe, we have CENELEC and ETSI as the main standardization development organizations, among others. Standards should always reflect the state of the art, and they are structured review, typically every 5 years, if required earlier. However, policies are revised when the policymakers think it is important to review the policies and to update the policies. I do explain this because we have with data space standardization a very specific setup at the moment in standardization. We talk on some standards, not only on European norms, European standards. We talk about so-called harmonized European norms that are typically created following a standardization request, where our policymakers sees a need to support the given regulations with technical standards. Then a standardization request is issued. That happened in Europe, for example, for AI, for the digital product passport, but also for the topic of data spaces, which is a trusted data framework. And then after the standardization request is issued, the standardization development organizations start in the mandated work to create those standards. Not all standards under the standardization request are harmonized European norms. The Commission also could ask for other deliverables. However, harmonized European norms are listed in the so-called official journal of the European Union that helps you to be compliant to the given law, in this case, to be compliant to the Data Act. If you follow the standard, you can showcase by that you're compliant to the European regulation that we have at hand here. So that is a short introduction, and I think it's important to know, and maybe you're interested to read a little bit more on that. As said, we talk about the Data Act here in this context, and the Data Act has a couple of articles. Especially at the moment, it is Article 33 that talks about data spaces or the essential requirements regarding interoperability of data sharing mechanisms and services, as well as of common European data spaces. We expect a standardization request on Article 35 on interoperability of data processing services in the future. However, that is not issued yet, so we are not under mandated work here at the moment. In general, standards are not only important to be compliant to the given law, to the European regulation. It supports interoperability. It supports trustworthiness and trust to ensure sovereign and secure data sharing mechanisms. It supports you in scaling. If we have a good foundation on standards, scalability and stability is, of course, better given than just, well, someone drops a nice specification and you can follow it or not. So this is in general why standards really support our ecosystems to grow and to adapt to the market needs. When we talk about standards in data spaces, there is an important distinction to be made because standards could be of different kind, if I may put it like this. We talk about conceptual standards that explain how things relate to each other and what given terms and mechanisms, what the concepts are, and they describe it. However, you cannot really implement that in technology, not in a really interoperable manner. So you cannot give it to a programmer and they can just build some code that will magically work. That's not the task for conceptual standards. Conceptual standard, as said, describes the concepts in detail. We also have technical standards that are typically really implementable. So you can take it as a blueprint, you can implement stuff, and then it should really work like given in the technical specifications or the technical standard that are given here. For example, with the data space protocol, this can be also tested automatically with testing tools that you're compliant to such technical specifications. Then, of course, and this is important, especially in the field of IT where we live in, that we have open source implementations. Open source implementations really help to follow a given standard or to support standardization activities in general. well, because we can really develop here some given code that can be adopted immediately in an organization to work with each other and to be compliant to some given specifications and standards, or they could support the creation of the standards, because we can really see how things work and what is really the gist of it that we need to standardize, where we need to collaborate in open source, and where we can differentiate on top of that. So this is important as a structure. However, I promised to talk about CENELEC JTC 25. CENELEC JTC 25 was created a little bit more than a year ago with a task to work on standardization in the field of data management, data spaces, cloud, and edge. I have the scope written down here. This is very broad in general. However, the first important task is the standardization request on the trusted data transaction. And if I may go to my next slide immediately. So this is the structure that we followed in JTC 25. We have created 4 working groups, and working group 1, an advisory group that picks up the work from the focus group on data spaces, cloud, and edge, that is looking for standardization requests, that is doing some stakeholder management and interacting with our liaison partners, with the European Commission. And also there's a standard analysis, so where are standardization gaps that can be fulfilled in the future. We have our working group 2 and 3 that work on the topic of data spaces and on data management and data governance. So this is really where the work currently happens on the standardization request. And we have a working group 4 on cloud and edge that is also started to create standards, as said, not under mandated work. However, we expect mandated work in the future, and there are standardization gaps in the cloud and edge. So when we talk about data processing services in Europe, and this work is also has been started already. What does this mean in more detail? So very briefly on the standardization request. So you can find it when you search for it, the Trusted Data Framework. It's a mandate number 614. It has been accepted in the summer by the standardization organization. So we're working on this, and we have 7 items here. The first 3 items are the so-called trusted data transactions. It's a multi-part standard with the first part on terminology, concepts, and mechanisms, so describing how the overarching thing can be explained and understood. The second part is on trustworthiness requirements, and the third part is on interoperability requirements. And you see the deadline for those also on the right side. The items 4 and 5, the technical specification on data catalog implementation framework and the technical specification on implementation framework for semantic assets. Those are conducted by the ETSI TC Data. And Diego will present this in more detail a little bit later today. Items 6 and 7 are also part of the work that is done in JTC 25, a European standard on a quality framework for internal data governance, and a technical specification on a maturity model for common European data spaces. So the maturity model for common European data spaces addresses the data spaces as such, their rule books and how they are structured, how successful they will be, how sustainable they are, while the European standard on a quality framework for internal data governance really addresses the data governance and management mechanisms within a data space participant. And you see that only the trusted data transaction, part 1, 2, and 3, are so-called harmonized standards. Where it is important to say that part 1 does not contain requirements, so it is a harmonized standard, but you will not find requirements, just definitions, concepts, and the key mechanisms. And the requirements are all in part 2 and 3. So this is quite a lot, so I have a big slide with a big table to give you a little bit more details. And so you can screenshot it or you will receive the slides later on, but this is the current status of all those projects, especially as we have started with the trusted data transaction even before JTC 25 was created in a so-called CWA, a CEN workshop agreement that was named trusted data transaction, where an initial version of the part 1 and also an initial version of the part 2 were created. Those documents are published. However, after they have been published, they have been handed over to JTC 25 to become a standard. Because the CWA does not produce a standard, it's a CWA result that should support standardization activities, but it's not a standard as such. So JTC 25 is now working on those initial documents from the CWA and is creating standards out of this, especially for part 1. We have finalized the second drafting phase. That means the document as such is finalized, at least from the perspective of the working group and of JTC 25. Now it's given to the national bodies to review it and to provide comments for the step that is a so-called formal vote. So it shall be approved by the national bodies. If the national bodies approve the Trusted Data Transaction Part 1, it will be published and then also listed in the official journal. For the Part 2, we are finalizing the first drafting phase. After the first drafting phase, the document is to the so-called inquiry stage, where the national bodies provide feedback and the feedback given. So it's not as mature after the second drafting phase. So we expect feedback from the national bodies to improve the document. And afterwards, it will also be sent to formal vote to be accepted. But this is still some time that we need to finalize the document. Trusted Data Transaction Part 3 is still in the drafting phase 1, in the first working phase. We will close this before Christmas, definitely. We're planning to end the drafting of the document in November, maybe beginning of December. And then this will also be sent to inquiry. As said, the data catalog implementation framework and the semantic assets are subject to ETSI data. I will not go into those details here today. The quality framework for data governance, also in drafting phase 1, shall be finalized also before Christmas. And the maturity assessment for common European data spaces also in drafting phase. Here it is important to mention that the maturity assessment for common European data spaces shall be a technical specification and not a European norm, so we don't expect a second drafting phase. So when we finalize the drafting of the maturity assessment for common European data spaces, it shall be sent to inquiry, and hopefully, if we don't receive any comments in that direction, it will be published afterwards, so during the next year. This is a little bit the overview, and I know this is a lot. However, this shall give you an impression where we stand and where you can support either from your national bodies or from participation in the working groups. I would like to explain a little bit in more detail what the Trusted Data Framework really is about. And I really like this graphic that was created by the European Commission because you can see the 5 items. As said, the Trusted Data Transactions are 3 items. So that means we have in sum 7 that boil down to 5 standards where they support. So on the one hand side, we see the data space as such that consists of a governance that has services that uses protocols or mandate protocols, where the different standards are built in here. So the maturity assessments to assess the data spaces as such, governance framework that shall be provided and should support the participants. Some services, especially for the data catalogs and semantic assets, and the key protocols that are described in the Trusted Data Transaction Asset with regards to trustworthiness and with regards to interoperability. The interaction in a data space between 2 participants, between the data holders and the data users, also supported by the different deliverables that we have from the standardization. So, and you also see that it connects and supports data intermediaries. Data intermediaries are not subject to the Data Act, but, for example, for the Data Governance Act. So even while the focus is on the Data Act, we, of course, touch also other regulations, and of course, we need to connect it to other standards in that matter as well. So this is a little bit the overview. However, there is one important key figure that I always like to present because it really describes clearly what the key concepts are. So this is surprisingly from Trusted Data Transaction Part 1. And you see on the lower left side, there is a data provider, and on the right side, there is a data user, and they both interact with each other. And if they wish to interact with each other, they should be interoperable. And here we talk about the key activities that are required to enable them to interact with each other. We talk about publication and discovery via a data catalog of data products. We talk about the negotiation of data sharing contracts, and then the actual data sharing process and the usage afterwards, the assess and the usage afterwards by the data user. So this is not surprisingly. What is important about Europe is on the upper left side, the data rights holder. And this is a specific thing that the Data Act talks about, that the data rights holders shall be enabled to grant rights to a data provider, and they could be really able to manage and control the data usage through the whole data value chain. And this is a key aspect that we have here in the regulation, and that, of course, we have here also on the standards as well. And of course, we also need to distinguish this from a data producer, because a data producer and a data rights holder could be also distinct roles in the end. Of course, in a lot of cases, they are combined, that the data provider, the data rights holder, and the producer are the same party. However, conceptually, we divide it. What is also important to mention is the data product. And the data product is a very specific thing that we have here, and I will go into more details just in a second. However, this is a key aspect of the standards that we have. As said, part one with the concepts, terminology, and mechanisms, as described here, and a lot more text. The interoperability requirements that you see on the lower part, described in part 3, and the trustworthiness requirements that are described in part 2. They are not nicely depicted in this figure. However, each interaction of the different parties that we see in the figure requires some degree of trustworthiness. That means I need to provide a claim and evidence that I'm acting on behalf of someone, that I'm acting lawfully, or that I'm acting as expected by contractual requirements. And this is, as said, part of part 2, where we describe those trustworthiness requirements, what kind of claims shall be provided and how they can be provided. The data product, as mentioned, is a very important aspect of the trusted data frameworks. And in general, what we understand here as a data product is a combination of data itself, metadata, and the services that are combined to the data. Well, without a service, you cannot provide or consume the data, and without metadata, well, maybe you can't even understand the data or whatever. So this is the understanding, and of course, from a broader perspective, a data product could be much more. It could include also some more business-related aspects, including some, for example, marketing aspects or whatever. But this is not a scope here. We really focus on those aspects, and metadata is a very, very broad term that, of course, connects nicely to this huge field of data quality that we also address partly. But as I said, data quality is a huge field. So we focus a lot on 3 key aspects here. The first one is, of course, the publication and discovery abilities. So how can I really publish data and make it discoverable, understandable with cataloging functionality? This nicely connects to the DCAT standard. And of course, the work that has been done on DCAT AP. And as I said, this is work of the HEDGE-IoT data, and we will hear more about this later on. It also includes, of course, the semantic asset part. So I need to understand the data from the syntactical point of view, but also from the semantical point of view. What is this data about? How do I have to understand a certain attribute, and how does it relate to other aspects? This is an important aspect of the metadata. And as said, the part with the data rights, so data sharing contracts and the rights associated with the data and the obligations that we have. This is also part of the metadata, and those are the 3 key aspects that we analyze. And of course, this can be nicely managed internally with a participant in data space via data governance and management in such a multi-stakeholder environment. This is an important concept. This is where I would like to briefly explain it here. However, we can also connect this nicely to international standards. And I will just go briefly through ISO IEC 20151. This shall provide a clear definition what a data space is. It's an international standard, so not European, an international standard. So you can understand, is this what I have here, a data space or not? And of course, it supports a baseline for interoperability, even while it's a conceptual standard. So what you find inside are the key characteristics. So you have a data space when you're able to maintain control, establish trust. You can discover data to support dynamic and flexible data value chains, negotiation of data sharing contracts. I'll be there in a minute, Sonia. I see you popping up. The orchestration of the data sharing. So we are not talking about a data lake where all the data is poured in, but it's really orchestrated. The data does not flow in or through the data space. Potential observability and interoperability mechanisms with those really important functional elements like multi-level policies, semantic asset and semantic models, communication protocols, and the processes and rules. I would like to close this with a key statement here. So International Standard 20151, general data space concepts and characteristics, supported by interoperability technical standards like the Data Space Protocol, Decentralized Claims Protocol, and a lot of others. And what we do here in Europe with a trusted data transaction, with a trusted data framework, is derived from our regulation, but it should fit nicely into this international standards as well. So because, well, data doesn't stop at European borders and we need to align and connect it with international standards. However, we need to be clear on what the European requirements are. So in closing with this slide, there are a couple of more standardization activities that I did not mention. However, and this is the role of IDSA, for example, and of our projects here, to keep all those different activities aligned. We need to act now. Time is short with given timelines on a standardization request. And this is my key statement here, we need to keep it aligned with the implementing activities like HEDGE-IoT and a lot of other implementation projects. We need to be aware what happens in the implementation, that the standards reflect what happens in the implementation, because we only have good standards and they are adopted in the market. And with this, back to you, Sonia.
Thank you so much, Sebastian. Actually, perfect timing. It was a great and very comprehensive overview. So yeah, thanks a lot. And now I would like to continue with our next speaker. So Antonio Kung, I see you're ready.
Yes, hello.
So, okay, so I think I will leave the floor to you directly so you can present.
Thank you. I'm going to share my slides. Hello, everyone. So I'm going to present something that is actually complementing, sometimes restating the same thing that what Sebastian presented. Okay. Speaker, probably you all know me. I'm from Trilog. We work on IoT, and we've been involved in standardization topic in many aspects. Okay. So just to show to you that in reality, when it comes to standards, all those, let's say, circles are committees, and you have below the JTC 25, but you also have SC38 plus others, okay? So we have data spaces, and they include all those things, so we need to know how to integrate them. So how do we do this? What we suggest, and we have also suggested to the Commission to use this approach, we would like to propose what we call the hourglass model, okay? An hourglass model was actually published in 2019, providing, let's say, a vision of the ecosystem where you have two layers and inner layer, a small layer, which provides the capabilities, okay? So below you have all possible supports, above all possible applications, okay? You can see applied to IP, you have Ethernet, Wi-Fi, SONET, on top TDP, UDP, and HTTP, and the rest, okay? So we want to do the same thing, but we want to do more, okay? So we want to explain the stakeholders, the capabilities, and the standards of the ecosystem, okay? And actually, in the future, we'll add a box. What about the open source building blocks, okay? So, but we have to do this for several ecosystems. You have the data space ecosystems. We have the cloud edge IoT ecosystems. We have the IoT domain ecosystem, and maybe we have the trust framework ecosystem, okay? They have to be combined, okay? But of course, for clarity, when we focus on one ecosystem, we leave the rest, we do not focus on the rest, okay? So I'm going to give you an example of how we can do this through, first of all, a data space-oriented hierarchy of standards. So we're talking about data spaces, okay? So first of all, this version was proposed by Javier as an exercise. It's an example, okay, where here you have stakeholders, such as data governance stakeholders, data users, AI service providers. And here you have the capabilities, such as data valorization, connector, credential management, data collection, digital sovereignty. And here you have standards, industry standards, data space standards, claim standards, based protocols, okay, things like that, okay. So and above all, so now I'm going to repeat what Sebastian has said. You have regulations, okay, quite a few, and you have JTC 25 and HCTC data, which are covering, let's say, the mandate 6114. I just remember from Sebastian's presentation, and you have this here a number of items, okay. So if we take that into account, I'm going to change a little bit the hierarchy, okay? So again, here I have the ISO vision. So ISO vision, so there's mostly ISO standards. So you have the data space standards and 2151 plus some others, okay? In particular, for instance, 26189 could be an important one in the future, okay? But and then you have the rest, okay, below, okay? I don't want to get into details, but I want to show that this is how we build the things, okay? And when we get to, let's say, a European vision, we are not going to use only ISO, but we're going to use CENELEC and ETSI, okay? So I put here, because I believe they are important, the JTC, sorry, it should be 25 here, okay? And the first three standards, which actually Sebastian has presented. And below, for interoperability issues, I put the HCTC data, the catalog and the semantic asset standards. Okay, so this is where we can put a kind of hierarchy of important standards from a data space ecosystem viewpoint. Okay, so I want to go into detail and show three standards, and the first one is already mentioned. I can go a bit briefer. Okay, brief by Sebastian. 2151. Okay. So 2151 is at DIS, so it's going to publish probably early next year or this year. Well, I will see, okay? Or I'll say early next year, okay? Next year, okay? So here you have the outline. So basically, it explains concept and characteristic and the functional components. And here you have the scope plus some aspect about what actually Sebastian mentioned, control phase, orchestration phase, and you have the roles of the participants in the data space, including the DSGA, Data Space Governance Authority, plus participants, okay? So, but the real message is in this slide, okay? On the left, you see that everything is around policies. So you have data use policies, the data contract policies, the data discovery policies, and the data space policies, okay? So, and you build the data space according to an agreement about all those aspects, okay? So what do you build? Okay, you build something allowing participants, P1, P2, P3, to share data according to the policies in a data space A, okay? And the blue lines are the agreements for about this and of course about sharing. Of course, P3 here is part of two data space, okay? And so he has agreement with P1, P2 and some other agreement with P4. This is what actually 2151 is trying to explain, okay? So I want to show another example, which is an architecture standard. By the way, Sebastian mentioned the fact that they are conceptual standards. And yes, all the standards I'm showing are conceptual. So of course, we need to populate that with the technical standards and the implementations. So 3188 is the digital twin in the data space, okay? So basically, what we have seen here, we have, let's say, the standards coming from, let's say, SC38 plus JTC 25. Again, I made a mistake. I'm going to correct that, okay? And then you have the digital twin vision, either on top or either below, okay? Below, it could be an asset digital twin. On top, it could be a smart city digital twin, and you can use 3188 as a conceptual standard, okay? So again, this is the same thing, okay? You have digital twin reference architecture. Actually, the scope is defining system fundamentals through architecture views. It uses well-known standards on how to describe architectures, and you focus on concerns and viewpoints, and you provide views. Okay, so we have two views: the foundational view, I'm going to show a little bit that, and the architecture pattern view, which allows us to specialize to energy, smart cities, smart manufacturing, and the like. Okay. So the building of a digital twin is as follows, okay? So you start with the expectations, you have the requirements, system requirements, you have the architecture, and you build the digital twin. You reuse the standards, the conceptual standards, because they allow us to have the same approach, and then you specialize it using patterns, okay? So you can use here data space patterns. you can use domain-specific patterns. For instance, cloud edge IoT patterns. Okay, and out of that, you can then have a digital twin that is actually connected to a data space and support the IoT, the edge, and the cloud. Okay, so there are three types of digital twins we have identified. One is when it is a physical system. So, for instance, an energy transformer. Okay, so it could be a physical target entity, and then you need to have sensors and actuators to have a digital twin, let's say, capability here, where you implement models, algorithms, and observation data. Okay, you could have a cyber target entity. For instance, I have the digital twin of, let's say, the French economy, okay, and which is actually on progress right now. So then you have the same thing, but the interface is a cyber interface because you have to collect the data that is made available. Then you can compute digital twins aspects, okay, and you have a mix. For instance, a vehicle digital twin could be mixing, let's say, cyber aspects like the state of the road and data aspects such as the transportation, the travels, and things like that. Okay, last but not least, you have interoperability standard, and I'm going to mention 21823-5. Okay, so here I'm adding here two standards. Okay, one is 19944, okay, which is about cloud portability and interoperability. It's under progress, okay, the new version, and you have 21823-5, which is also under progress. Okay, so the standard is as follows. It provides principles for behavioral and policy interoperability. Okay, it provides requirements on behavioral and policy interoperability information, and it describes processes to develop behavioral and policy information. Okay, so you have the principles, you have the process, and the results are the profiles, interoperability profiles, and whatever information that you need to have to achieve interoperability. So the context of 21823-5 IoT behavioral and policy interoperability is that it is actually a sibling to 19941 provided in 2017, cloud computing distributed platforms, interoperability portability, and based on 21823-1, which is the framework. The two are actually, I would say, nearly twin standards, okay? One focusing on cloud and one focusing on the IoT, okay? Well, the reason why they are similar is because I think the same experts were involved in their creation, okay? Now we are working on extensions, in particular due to data space here and also to AI, okay? So we have 19941 edition 2 that is underway, 21823-1 edition 2 underway, and 21823-5, which is the one I'm presenting, okay? So here have the dates, and we are here on CD stage, okay? So CD stage means committee draft, which means that it's already taken care of at national level. So what it is we are trying to do in this extension, okay? So I want to show that in the past and until now, we were more in this picture, so now, okay, where we had to explicit the syntactic and transport aspect, but the semantic, behavioral, and policy aspect were implicit, okay? With the advent of data space, with the advent of AI, we need to make explicit the semantic, the behavior, and the policy facet, okay? And that's the reason why we are reshaping those standards to make more visible the fact that actually those kind of information on semantic, behavior, and policies are part of the data space. They are exchanged, they are metadata, they are policies, they are behaviors, they are exchanged, okay? So one example is the EU Joint Research Center Code of Conduct for Energy Smart Appliances, which actually is considering domain A being the smart appliances and domain B being the grid, okay? And now you get into the situation, you need to explain the semantics, the behavior, and the policy facets, okay? The code of conduct will also include the energy management systems and the charging stations. Okay, so how do we plan to do this? Is that we have the 5 facets, okay? Then we need to use semantic interoperability, so we need to use concepts and terminologies that are, let's say, a reference, okay? So we call those things concept profiles. So what are the vocabularies, the terms we are using in order to describe the semantics, the behavior, and the policy of a system, okay? And in order to, let's say, meet the regulation, okay, so it would be good that we associate with the profiles what we call constraint profile, which are actually specifications of what it is you want to observe in the semantic, in the behavior, in the policy, so that you match the regulation, okay? So once we have implemented the harmonized standards, the constraint profile will become very important because they're going to be used to for conformity assessment that we meet, that the interoperability profile meets the regulation. And again, this hypothesis of presumption of conformity. So I presented the data space vision. So it's a distributed orientation. But remember that HEDGE-IoT is also working on the cloud edge IoT. So we need to have the same thing, but with a different vision, okay? So I use this is my one slide, okay, where we can also start for the cloud edge IoT, and you see that at this point, the data space standards are below, like here, you have 2151, okay? And CENELEC, no, so here only here you have whatever, let's see. Yeah, so that's the only one to my knowledge, okay? Okay, so we put here on top some other standards. Yeah, I put here SC41 and here HEDGE-ISRF, which is actually the standards that are going to be used for the standardization request on the Data Act, okay? So this is the vision we can have, and the message is actually we use the same standards, but we have different perspective of them, and we put forward some standards that are more important than others depending on the ecosystems, okay? And here we have 2 visions, the data space ecosystem vision and the cloud edge IoT ecosystem vision. Okay, so this, I am done on my side.
Okay, thank you very much, Antonio. That was just a very comprehensive overview of all the standardization activities. Also, very good to have shared the link to what we're doing in HEDGE-IoT. And yeah, thank you again. And we will continue now with the next presenter. I will briefly share my screen. Okay, so now it's time to see what we are doing within the project HEDGE-IoT with regards to standardization activities. So I would like to give the floor to the next presenter, Leo.
Yes, sure.
Leo,
Let me share my screen.
okay. Good, so the floor is yours.
All right. So good morning, everyone. So my name is Leo Kornek. I work at Trialog, and today I will update you about the ongoing activities that we are doing in HEDGE-IoT about the standardization contribution. So just for the context, has many other European projects. It's just project is structured in work package, and the task around standardization is part of work package 7 with the objective to leverage existing standards and standardization activities for the project purpose, but also to contribute to standardization based on the project results and activities. And this goes through the development of new standards to fill the standardization gaps and also to update, contribute to existing standards. So at the beginning, one of the ideas was to identify what is our target, what domain are we targeting based on the topic of the project. So we identified 3 main domains. The first one is connected, intelligent, secure data ecosystem, with a contribution on standards related to data space, IoT, interoperability, digital twin, edge cloud continuum, trustworthiness, and AI. Then one of the main targets was on semantic interoperability. So all the standards related to semantic interoperability, including SAREF and its extensions. And the last axis was around energy and smart energy domain. On those 3 topics or 3 axes, what are the activities we are doing in HEDGE-IoT? So we are doing some internal workshop to foster collaboration of the partner on those specific topics. For example, we did one on data space, AI, energy, and each time we try to identify what could be the collaboration of the project, how we can contribute to standardization on this topic, and what are the activities done by the HEDGE-IoT partners on this topic. Then we are also doing some participation and contribution to standardization group and other bodies like IoTI, BDVA. We are participating and contributing to new standardization project or to standards revision project. We are also reviewing the 2025 rolling plan for ICT standardization to see how HEDGE-IoT can contribute to this plan and how our action are aligned with the requested action in this document. And a task that will come and will start in the upcoming weeks and months is the standardization gaps. So it's the identification of new standardization gaps based on what we are doing in the project. So HEDGE-IoT is involved in a lot of standardization group. As you can see on the table on the left side, it's mainly at CENELEC, ETSI, IC, and ISO. I won't go through all the standardization groups, but they are mainly all related to project topics. And we are also contributing to other bodies like AIoTI, BDVA, Bridge, but also Eclipse. And there is also other groups. It's not an exhaustive list. Now I want to detail a little bit more about what we are doing in each axis. For example, for the standards related to data space, IoT, interoperability, digital twin, edge cloud continuum, trustworthiness, and AI. Here are some examples of active contribution HEDGE-IoT partners are doing in standardization. It could be ISO IC 21823-1 or -5 as presented by Antonio just before. It can be also EN 304-199 guidelines for data catalog or guidelines for semantic interoperability done by TNO in the context of ETSI. Some contribution to GRC code of conduct as well. So here are some examples of contribution for this axis. Then on the second axis, we have some contribution to the new major SAREF release done by TNO mainly at the beginning of the project. Now this version is released. We are also we are having some continuous reflection on SAREF governance and the GRC code of conduct. We plan some contribution on SAREF suite of ontology, SAREF extension, and SAREF related applications. How to improve it, how to extend it based on a new concept identified in the project. And TNO through ETSI is contributing and monitoring EN 304-199 guidelines for data catalog framework and EN 303760, Guideline for Semantic Interoperability. Those two are related to data spaces and semantic interoperability. That's why they are in both axes. And the remaining one on energy, we have an active participation and contribution to the GRC Code of Conduct Energy Smart Appliance. As a reminder, it's a voluntary initiative. And we are also having an active contribution to the coordination group on smart green. We have an active participation and monitoring of IEC 61850 series, and more precisely on the data modeling. And of course, we plan for the contribution on this on the topic of energy a bit later. So as a conclusion, at this stage, the contribution of HEDGE-IoT in standardization is already ongoing. We already have a lot of topic and contribution ongoing. We should continue on this direction. And one of the main work remaining is this alignment between the 2025 ruling plan for ICT standardization and the analysis of the results of the project and the key exploitable results to see how we can contribute to standardization. Then, of course, we will continue the standardization watch to ensure that the project is aligned with what is happening in standardization. And we will try to create some synergies with other projects, continue to be involved in national bodies and to do some liaison. And one very important work will be to the identification of standardization gap. So that's it for the activities done in HEDGE-IoT right now. Of course, it will be more extended a little bit later. And if you have some ideas on how HEDGE-IoT can contribute to standardization, feel free to contact me or the project partners to try to create some synergies. We would be very happy to support you. Thanks.
Great, thank you so much, Leo. As you can see, there's a lot going on in HEDGE-IoT with regards to standardization activities. And now let me introduce you to our next speaker. So now my dear colleague Silvia Castelbí from IDSA, who has broad experience both in R&D projects and standardization, will explain how HEDGE-IoT can contribute to existing standards. But since we have colleagues from other projects as attendees, not only from HEDGE-IoT, I think this presentation will also serve people working in other projects to see how to align the work done in the projects with current standardization activities. So I would like to welcome on stage Silvia.
Thank you, Sonia. Yes, Leo has did a really good presentation, and we can see that they are experts on standardization. So you can see but for others, and also to follow up on the gaps identification that the HEDGE-IoT is going to develop, then we can, the purpose is, okay, if we identify in the research projects, in HEDGE-IoT or in other projects, what is missing, something that we propose to change in the standards, something that is missing, the gaps, then how to transfer this to the standardization bodies. And as Leo has presented, there are different ways to engage with the standardization body. One could be direct participation on the technical bodies, as Trialog and TNO as part of HEDGE-IoT is doing. So promoting the engagement through networks or participating through national members. Also, another way to if we see a standard that is developed under a committee that is close relation with HEDGE-IoT, we can establish a project liaison with this standardization body, and then one representative from the project participate directly. In the case of CENELEC, under CENELEC Guide 25. But also, we can interact with the standardization bodies, informing the standardization bodies about the, for example, experience of implementing the standards, contributing to the ongoing standardization developments. Under the standardization developments that are public inquiry phase, but in order to contribute to this public inquiry phase, we need to have representative on the technical committees, as explained before, Leo, by trialogue, TNO, in this case for different. Or, for example, in HEDGE-IoT, we can identify the need for a development of new standard. So if it is the case, then we need to assure that doesn't exist previous standards and that this is really needed, and maybe discuss with standardization bodies related to the gaps that we identify why this new standard is needed. Okay, so in how a HEDGE-IoT can make interaction with the standardization bodies, there are different types of contacts. Two of them, one is inform about project activities related with the standards and writing information about technical committee body work plan and interest on future standards work. This is what we are doing here with CENELEC, and if our next speaker, Diego, arrives with ETSI also, and also Antonio Kuhn has explained it on different standardization bodies. We can see here the plans, the work plan, and how we can participate. Also, participate in the technical body meetings to get more detailed information and discussions on interest for HEDGE-IoT. And also another way to establish this interaction is invite representative of the technical committees in the events. In this case, in this workshop on semantic interoperability, but we can invite them on the advisory board or general assemblies to establish interaction and collaboration. And also, we can, as said before, we can contribute to the ongoing standards development. We need to identify, based on the experience that we had to participate in different standardization activities, part of the research projects, we need to identify the priorities of the project and also the partners that are able to contribute, because sometimes we implement a lot of standards in the project, but not all the partners has the priority to contribute to this standard. So it is important to identify the standards and prioritize which standards we want to influence, we want to recommend, and then the ways to participate on these standards that we prioritize, because we are able to put efforts, because contributing to standards requires a lot of effort. So then we need to commenting and proposing content for the draft standardization deliverables. But for that, we need a representative of the project that participates, okay? Application for project liaison, as commented before, or participation through national mirror committees, or in the case of IDSA data spaces, you can participate on IDSA activities, working groups, and contribute. And then, as commented, you can realize that a new standard development is needed, and then project can justify, well, recommended a technical body to start a new standard or modify existing standard. Okay. As a previous state, I have not included on the standardization slides, on these slides, but you can organize from the project or in collaboration with other projects as a CENELEC workshop to analyze these gaps and propose the new standards. And I hope that's all, Sonia, just to provide an overview on how we can contribute to current standards from research projects.
Thank you so much, Silvia. That was also very helpful. And okay, then let us move on to our next topic. So we've been focusing on standardization, but we would also like to share the current activities that we are doing with regards to semantic interoperability within HEDGE-IoT. I'll also like to just as information, I mean, we're halfway through in the project, so there's still work to be done, but we'd like to already share with you the achievements from the first half of the project. Also, as a reminder, feel free to write your questions in the Q&A section, because we will have at the end some time for questions from the audience for our speakers. And okay, and now, yeah, I'll give the floor to Cornelis from TNO, who will give this overview on the semantic interoperability activities of HEDGE-IoT. So Cornelis, yeah, the floor is yours.
Yes, thanks a lot, Sonia. So in this presentation prepared by Laura, Daniele, and myself, we wanted to give an overview of the current semantic interoperability task and activities in HEDGE-IoT. We're from TNO, so the Dutch Applied Research Institute. But as well, we would like to give a short overview for the people external to the project about HEDGE-IoT. Because we're supporting the green and digital transformation of the energy ecosystem and enhancing its resilience. We started already in 2024, and as Sonia said, so there's some still work to be done, but there's also time for some work to be done. And all that work we are applying in 6 pilots throughout Europe: Finland, Greece, Italy, Netherlands, Portugal, and Slovenia. And all the semantic research that I will be showing in these next 10 minutes. We're applying there, for example, in the Dutch pilot, transforming the electricity campus, Arnhemsbuiten, and applying there all the semantic technology for energy sustainability. And in this project, we're with quite some consortium members from all different types of organizations, from academia, applied research, standardization, DSO, TSO, as well as several of the pilot owners. And I put this here also for reference when you receive the slides afterwards via email. And the project has, of course, also set quite some goals. And I think the main goal that I want to share, and because that perfectly aligns with also the semantic interoperability task, is here the third of these objectives. It is to enable extended service and semantical or ontological interoperability and interconnectivity among distributed open platforms, systems, and edge devices. And that we do that through a decentralized ADS compliant interoperability framework. And so there you see the part of interoperability that both concerns the architecture or the framework that facilitates the interoperability, but as well as the semantical or ontological models that support the data structure. But from that, I want to zoom in on the specific part of the project that we're working on. Here are the same slide as Leo showed, but we're in a slightly different part. We're in the task about digital interoperability enablers, and within that task that concerns itself with data space components, with cybersecurity, and with app stores, we're specifically focused on investigating the semantic interoperability. And within that task, we have various subtasks or subgroups that we're focusing on. I categorize them here into technologies, so actual tools that various of the partners are working on that can really help you in applying semantic interoperability in whichever use case or whichever pilot. Additionally, semantic models. So really conceptual models that will describe how the data can look in a semantic, intuitive, easy to reuse way. And thirdly, frameworks. So really the conceptual frameworks that can facilitate our understanding of how working with semantic interoperability will work. And in a sort of popcorn way, in the next few slides, I will highlight a few of those. But I will also briefly go over them. PowerSim is a very interesting tool developed by Conchar for grid data exchange based on the Common Information Model, which is standardized at IEC. We also have, in terms of data space components, the Semantic Treehouse. I think some people may be familiar with that tool from other projects such as EnerShare, which is being positioned as the data space vocabulary hub, where the common languages throughout the data space can be located. We also have a semantic interoperability framework developed in the H2020 Interconnect project, which is currently being standardized at the Linux Foundation for Energy, which really functions as a semantic middleware. But then going to the semantic models there, SARAF, the Smart Appliance Applications Reference Framework, plays a major role because we are also here looking at further extending it beyond just the SARAF Energy and the SARAF Grid that already exists, but also investigating the alignment with other standards from energy such as IEC SIM and also IEC 61850. And thirdly, for the frameworks, we're looking at different standards, but also looking at a new set of HEDGE-IoT semantic interoperability levels, and also looking into behavioral testing together with Trilog, about which Leo and Antonio have already shared quite a bit. So first of all, I don't want to go through all the details of these slides, but also the existing European Union interoperability levels have been identified as being a little bit outdated with them having been developed already about 7 years ago. So also for this project, we have been working on new ones. Going from the lowest level, the least amount of interoperability, to the most advanced semantic interoperability. And one of the key features of our project is that we take a level 3 of technical interoperability via data space connector as the minimum level. And then per use case and per pilot, we want to see to which higher level do you want to raise the pilot, and which higher level does actually give you a benefit in the use cases that you have. I think this aligns with one of my favorite quotes about semantics. A little semantics goes a long way. And so going to level 4 or level 5, it can be sufficient, but in some other pilots, going really to level 7 of the advanced semantic interoperability may be what you need and what you require. The other part of the work is the work on Semantic Treehouse, which we are extending with making it easier to use with SARAF, which we're extending with making it easier to align with the semantic interoperability framework. And as you can see here, it perfectly positions itself as the vocabulary hub, where all the information about the knowledge bases in the data sources in a data space can be shared. To really describe it in a formal way via DCAT, such that for all the participants in the data space, it is clear and ambiguous which kind of data is available here in this particular data source. And thirdly, on the level of the frameworks, we're currently working on a reference architecture where we really fit all these interoperability enablers into a nice diagram. There's also work being done in collaboration with the European Dynamics. And really the goal is to show the position of all these interoperability enablers, because you see here in yellow various of those technologies: Semantic Treehouse, the ontology-driven constraints cluster, OCT, PowerSim, Knowledge Engine, which is the other name of the semantic interoperability framework, and they all are interoperability enablers, but all really have a different goal in your architecture. Putting these nicely into the architecture will also show the gaps in the coverage of this tooling to show how this can be further extended for what's additionally needed. And additionally, this is useful to identify which of these tools actually are running on design time and which will be running at runtime to really do the real-time energy management. When we turn to the semantic models, like mentioned, the SARF and particularly the SARF for Ender extension is quite important for us. And in case you're already familiar with SARF, you can recognize the picture at the bottom because it shows the structure that SARF has a SARF core, which is horizontal, so which is really generic across use cases and across domains. But additionally, there are various verticals from a lot of different domains spreading quite beyond just the energy domain of this project. But the important ones for us are SARF for Ender, SARF for Grid, and in some pilots also SARF for Building. But the information and use cases coming from these various pilots can also feed back into SARF for Ender and also the various other extensions to increase the scope. And additionally, we are aligning here with external standards such as SIM and aligning with additional tools such as ODCT and Semantic Treehouse. Then these are various diverse subjects, and we're also putting all of this together in a set of learning materials in this online repository. That's as the last thing I wanted to show from the work on semantic interoperability, because we have identified various times that some learning materials may be absent or may be spread across various locations. So this link, it may even be already clickable in your screen, and otherwise we'll put it in the chat. And we collected various webinars that we gave during the task for the 3 meetings, where we really prioritized clear practical educational resources and to onboard new partners, but also external stakeholders. So it will also serve as a portfolio of pilot interfaces to be extended for interoperability. So be sure to take a look at your convenience. So with that, I wanted to give you a high-speed broad overview of really the various diverse tasks that with all the partners collaborating in task 43. We are working on this, working on technologies and learning materials, working on semantic models, and working on frameworks that increase our understanding of applying these semantic technologies. So thank you, and back to you, Sonia.
Thank you so much, Cornelis. Great overview of the current activities with regards to semantic interoperability in the scope of HEDGE-IoT. And now I would like to introduce you to our next presenter, who's joining from very far away. So special thanks to Diego Lopez from Telefónica. And I saw, yeah.
Sorry, I was muted. Sonia,
okay.
No, simply that I forgot. I forgot to mute. Sorry.
Okay, I know it's very early for you in the morning, so thank you so much for joining us.
It's a pleasure anyway.
Okay, so Diego will give us an overview of the activities of ETSI ETSI data. So I will let you share your screen.
Okay, so let me. 1 second, because I have an issue with my. No, it's being shared, right? Okay, so well, Thanks for the opportunity and well, sorry about being muted at the beginning. I was trying to be discreet when I connected. I am currently attending the ITF in Montreal, and it's, for me it's 6 something in the morning. Well, the idea is just to introduce you to what we are doing in ETSI, a new initiative that we started with the well, actually in February this year on distributed on data solutions, and well, it's we refer to it as an open, trusted, and distributed data solutions. Is a group called TC Data that is born, but with the idea of joining efforts and gaining critical mass in the different activities that ETSI in the past have been has been involved regarding, in general, data solutions, data infrastructures, data products, etc. So the justification for this, or the motivation, or where we come from, is this idea that well, data in general and how data is delivered from one point to another is essentially, if you think about it, anything that has to do with data networks is essentially this. With the difference that, or the additional points that, as we recently we are witnessing an increasing the increasing request of different applications that are not right now any longer they're not any longer basically or totally deterministic, in the sense that well, we're talking about here about agent applications. It's a term that we coined, trying to be a little bit or to consider a wider scope that just saying that we are doing things regarding artificial intelligence, or trying to go beyond that. We're doing what in these recent months has become the AI agents that are basically will have very strong characteristics. Basically, the point is that we're witnessing this evolution in which there are more autonomous applications that are able to behave according to intent declared by the users, that are able to collaborate and select the appropriate data they want to consume and they want to produce and to share, and that are controlled by mechanisms that are as I said, non-deterministic. They're not purely procedural algorithms, but they are subject to mechanisms like inference or the idea that they can work following natural language, etc. Something that is important, and is extremely important for a group like ETSI that is focused on telecommunications, is that they are necessarily, or in many cases, they are distributed. On the one hand, they are executing in using a network and networked facilities as essential on the one hand, and second, that they are multi-domain. That implies the usage implies the interconnection of different domains and the collaboration among them, which is something that, well, if you think about it, is a characteristic about the network. And as I was saying at the beginning, we're talking about data networks, data interconnections, and that's basically what we are trying to explore. By the way, this is something that has been acknowledged by the ETSI community for quite a long time, and this is has been part for some time of the ETSI technology, rather. With these pieces and taking into account this situation and the interest of different members of the ETSI community in exploring the space of these distributed data solutions, there was some internal discussions in ETSI during they lasted for around 1 year during the past year, about how to, as I said, gain critical mass and make converge the different initiatives that are already existing in the group to enhance the impact and try to address aspects that we consider that specifically when we're talking about something that is related to the network and the network services around this open data sharing were required. With this, we discussed about this, and there was a clear consensus that it would be interesting to have to have an initiative or do position ETSI in the space of data solutions, very much focus, let me say, on networks themselves and how networks can support and even provide as a service for mechanisms associated with these data access or data exchange that has been as much autonomous as possible. And well, consolidate, as you have here the list, consolidating open solutions, trying to widen the possible applications domain, and focusing very much on aspects related with privacy and security, and in general, the European concerns about this in terms of open standardization and regulation. So the TC data was started to work on the, as I said, in February this year, was formally approved at the end of January during an ETSI board. And well, we are trying still, you know, that this in standard space, everything requires time to build consensus and to decide a common way to go, but we are still working on making it work in a seamless way. The goals, as is said at the beginning, is about having open, distributed, and trustworthy data solutions. When talking about openness, is about, well, the openness is at the base of standards, and the idea is to support the autonomous use of data by agent applications, and these agent applications, in the sense that they are more or less autonomous, are connected to intent and with the expression of intent and the use of natural or close to natural language. And the important point is that we are intended and we are committed to support these agents applications behaving autonomously, etc., on any other data-driven technology. And part of the targets that we have for sure are the integration of IoT mechanisms, edge technologies, the cloud continuum, etc. Aligned with these fair principles of making data and data results findable, accessible, interoperable, and reusable. According to appropriate, correct data governance that is going to be enforced by the different infrastructure components. Data governance, and again, this is something that from the beginning we are trying to address, is a data governance that is applicable for all data transactions. That implies for discovery, that it implies for consuming data, and that implies applying the data governance as well for producing data. Because what we have within the scope is addressing the whole data pipeline and the whole data exchanges in this environment, and facilitating this open environment for collaboration based on data exchanges. And that includes, for sure, aspects regarding access control, let me say, in both directions for producers and consumers, guaranteeing that the data is consistent and that it provides to provide a consistent set of metadata about those data available, and consider something that is important, that is regarding privacy preservation when talking about personal data, and confidentiality when talking about corporate or organizational data. And for sure, something that from the very beginning, I believe is, at least for companies like mine, and in many cases, in general, in the case of the telco space, something that is quite important is about avoiding the natural trend of humans, that is about reinventing the wheel. We are trying to avoid repeating in ETSI the same approaches that have been followed elsewhere. We are very much interested in leveraging existing data spaces and facilitating their use and integration. We are not thinking about defining new data spaces or defining new semantic fields, with the possible exception of the telecommunications networks themselves, where we have identified a gap. But the idea is to facilitate the use and integration of existing data spaces and leverage them, trying to avoid these, as I said, these not so unusual human temptation to reinvent the wheel. We're talking about the other, or the second characteristic about making them distributed is basically addressing, on the one hand, the concept of data productization. So we are considering how support decentralized data management paradigms is something that there is a strong interest. We ETSI is a group of organizations that are very much focused on network services, and the idea of whatever that has to do with the decentralization and how you can manage data in a decentralized way. And then we are considering aspects as approaches like as data fabric, the data mesh, and considering the impact of knowledge graphs, and dealing with semantics, and making the whole support for these data solutions the combination of data and semantic, data, metadata, and especially semantic metadata. And something that is important even directly for us as consumers of the technology. I mean, from companies that are involved in the networking spaces, about data integration. There are many activities, and in particular networking, that implies an extremely heterogeneous environment because of the nature of the services that we are providing, and because of the historical evolution of those services. And think about that. We started with what now are called fixed networks. We are mobile now. We have now mobile facilities that are disparate with respect with these fixed networks. We are moving right now in the non-terrestrial and satellite networks, and that implies that the data sources, the way in which we are producing the data, we are transmitting the data, storing the data, is extremely heterogeneous, and there is a strong risk of falling to the creation and the use of data silos. For this, as I said, in ETSI, we are starting we are not starting, TC Data is not starting from scratch, and there has been a strong work addressing context, information, context sharing, and data in context, and with the idea of something that is called, and I'm sure you're familiar with, GSILD, and the APIs associated with that. The other side of the distributed data solutions is the support for ontologies, and how ontologies can be applied for progressing and making available semantic content, and for these autonomous agents, or these autonomous data consumers and producers to be coordinated and identify the different data and leverage data representations to apply them to the domain of interest. And we are trying to address challenges that have been associated with ontology development and management since we the concepts with the Web 2.0, etc., started, and with the modeling of these this ontological knowledge about data. And that's it's about how you link experts, how you or knowledge expertise, how you provide suitable tooling, how you facilitate a consistent methodology that can be applied. We are very much, and again, ETSI and teams in ETSI has been working on aspects related with this methodology, and using this approach of the linked open terms, And with the idea of, as I said, with respect in data spaces at large, and in particular with ontology, the ontologies related to them, avoiding reinventing the wheel and providing a set of methodology and validation tools that can be used for the integration of these methodologies and the application for the cooperation among the different potential applications that will be making use of a particular data exchange environment. And for this, again, we were relying on the availability of SARAF as a core ontology and as a methodology that we are consolidating as one of the main foundations of what we intend to do in this within the work of TC Data. Finally, the other aspect that we consider are trustworthiness and how you build trusted data solutions. Here we believe and we believe that there is a challenge that is still needs a clear technology approaches, etc. This is about how you identify the workloads, how you properly identify the different actors in the autonomous data exchange among these applications that are participating in a particular environment, and how these taking into account that these entities are non-humans. There is a lot of work. There is a comprehensive corpus of technologies and proposals, and protocols, and solutions that are focused on human identities. We are talking about providing proper identity for non-human entities, for workloads in general, to refer to things that are executing, again, in most cases autonomously on top of the data field. And well, it's essential that we connected them to human identities. At the end, it's about, well, that you have a workload that you have identified, you know about its attributes, but you have to relate it to a human because of, for sure, legal and well, even ethical requirements. And that becomes not only an essential enabler for guaranteeing trustworthiness of security, but this also can become a network service by itself, as we have right now with human identities. There are issues, and this is what I said, that probably this is the most open the most open aspect now that is considering this data. I mean, talking about what are the, well, as I said, there is a very strong corpus on human identities. We need to evolve this, and we have to associate it with mechanisms for policy management, for proper accounting and auditability, and consider all the implications it has on security and privacy when at the end you have something that is linked. You have an identity that is associated to a workload and is linked to a human. We are currently exploring and discussing the first applications in data governance and trying to extend, as I said, the scope and the focus of different enabling technologies, and in particular, wealth has become a commonplace in current technologies. And we are trying to address as well two aspects that are, on the one hand, important to guarantee the usage of data and to make it trustworthy on the one hand, and second, that they are sustained by data themselves, and that can become, as in the case, in the general case of identity, can become a network service, a distributed data-enabled service by themselves. One is the mechanisms associated with provenance, in the sense that when you have a set of data sets or data products, you can get a reasonable guarantee where the data come from and which have been the processes it has been subject to. So a clear track how the data was generated have been processed can be established. And with these support mechanisms for accountability, for auditability, and even for providing a new data economy in which you connect producers and consumers of the data. On the other hand, is about evidence, how you can collect, accumulate, and provide support for evidences for, on the one hand, making decisions on policies and applying them and feeding data that is trustworthy to these autonomous applications on the one hand, and second, how you can support whatever the mechanism you believe is required to support a posteriori applications. Like, for example, something that is you can imagine to sustain an economy environment based on this is about simply billing, how you make people pay for the data they are consuming or paying for the amount of resources they are planning to consume and the other way around, and facilitating the offering and the consumption of these data, data products. And on the other hand, and for sure, the accountability, the identification and tracing of any security and privacy breach, etc. That has been sustained by this evidence that is related with this. Basically, if you think about it, is another number of data sets that are related with the transactions that happened in the data space. We are still trying to identify base or the foundations for these activities. There are ongoing work, for example, here in the ITF and elsewhere, but where there are problems regarding how good you are building data and data sets, how you accumulate these evidence and provenance, the level of granularity, etc. So we are working on this, and this is, in my view, the trustworthiness aspects are one of the most relevant for the kind of scope that TC data has. Which right now and in general is, as I said, is about these three aspects relating these open, distributed, and trustworthy network solutions that trying to address everything. I mean, it's not that we are limited or we have not limited ourselves, sorry, to the just a solution, the aspects regarding connectivity, because we believe that if we're doing this and think about the evidence requirements, we need to consider as well storage. And we, in a distributed environment, there is not that clear what is pure connectivity and with this transformation of the data. So we are thinking about considering mechanisms for enabling data solutions in these three main dimensions. We are aware that this is not starting in open space, and that we need to collaborate with other standards organizations and essentially open source communities in building a healthy ecosystem. And for sure, ETSI, the E for ETSI regards to European, and we are very much interested and committed to collaborate in addressing European policy and regulatory mechanisms. And in particular, in this aspect, we are addressing a standardization request for the European Commission on the Data Act in collaboration with the CENELEC JTC 25. We are focused, and if you think about it, it's natural because it has to do with basically the two aspects I mentioned before on the open and distributed aspects, and how you discover data and how you provide metadata, semantic metadata exchanges. Apart from that, and focus on that, what we are trying to do is to leverage and continue working on the results of the groups that were at the origin of TC data, and that includes TC Smart End-to-End and SAREF, ICG CDM on maritime, same, I mean, ICG same, we're talking about NGSC, NGSI-LD, and PDL talking about technologies related to distributed ledgers or good blockchains as you wish. And we are looking as well, and CDM is there because we're looking at different relevant vertical applications, and in particular CDM was dealing with maritime communications. We are collaborating with other groups in ETSI that work in related aspects that rely very much on these open distributed trustworthy data solutions, like the one on digital identity, ESI, or on legally retained data with TCLI. And well, we're trying to address discussions that are ongoing right now in 3GPP in defining data solutions and potential data services provided by and supported by the mobile networks. We are very much focused, as I said, on the foundational technologies, SAREF and NGSI-LD, and we're trying to start something that is important, which is the framework for executing POCs, proofs of concept, as demonstrated deliverables. We are committed not only to provide specifications or to perform studies on what is required to satisfy standardization requirements, but as well to support the realization of practical experiments, the dissemination of these practical experiments, demonstrating how certain technology can be applied, or evaluating trends and provide these demonstrative results that can be used by the industry. And well, with this, I thought that they have. Sorry, time is not that appropriate, and I was sure that I had a final slide with some picture, but this is not the case. With this, I have finished. Thank you so much for your attention, and I'm open to whatever comments or questions that you may have.
Thank you so much, Diego. Great to have this overview on the activities that HCTC Data is conducting. Great. So I'd like to ask you to stay on stage, and now I would like to invite also Antonio and Sebastian for the last section, so for the roundtable. I see there's a questions from the audience in the Q&A for Cornelis. So Cornelis, feel free to either reply there, or we can use also the last minutes of this session for the Q&A from the audience. But so let's start with some questions. So first question that I would like all the speakers to answer. So an open question, what is from your perspective, what are the main gaps or challenges that still hinder interoperability across energy and cross-domain data spaces? So who would like to give it us? I see Antonio. Yeah. Antonio's ready.
So
okay.
We're talking about interoperability, and we have agreed the semantic interoperability is important. Okay, we are working on that. But one of the main issue is for cross-domain is the governance. Okay, well, if it is the governance between the same SDO like ISO, that's going to be easier. But if it is between SDOs working different, which are different, like ETSI and ISO, it's going to create a problem. So, and this is what we saw in the code of conduct. So it's a management issue. It's not a technical issue. So we can solve it, and we need to solve it. And I think the stakeholders are aware of that. So this is very important. That's the first thing. The second thing is, once you have done this, you also need to have assurance and conformity assessment. You can even go to certification. So when it is again in a given, let's say, committee, that's easy. But if you have two committees, that's not easy, in particular when you need to contextualize. So for instance, something that is very generic, like 2151, and then you apply it to energy. So then you have specific requirements that you have to check. And this contextualization is not a practice that is well understood yet. I think so mature in SDOs. Yeah.
If I may add on
Thank you.
this, fully agree to your comment, Antonio. However, I think there is a second aspect of standardization that is really still required and where we see some gaps, because standards are not only, and I mentioned this during my presentation, standards are not only written on paper or written in an ODP or wherever, they are also part, and especially in the IT sector, part of open source development. So we can collaborate when creating common open source technology. That's also part of the standardization activities, where organizations come together, agree on running code that they, as I mentioned earlier, can use then afterwards in their organizations, or take this as a reference and implement their own. And I think this is an important aspect that we need to foster and increase, the collaboration in open source development to support the ongoing standardization elements, as said, especially in the IT sector where we live in.
I just fully agree, and I want to say that in the hourglass model, we have positioned the place of open source for the future. Okay, and this is a work ongoing, and we're still beginning there. But the good thing is that when it comes to data space, we have already some avenue of work, and we have the EDG data working group. Okay, so we are there, and I think people have to have aware that they should embrace that, because otherwise you create also a silo at implementation level. Okay.
Yep.
No, the point of the collaboration with open source and even if you, I would say that it's not only the collaboration. The point is that you or should be required that we apply, so to say, open source best practices to standards. There is something that. But too often the standardization process, consensus is complicated, consolidating the consensus is complicated, but we have to be aware that the world evolves in a quite different way from what it used to do when many of the standardization rules and mechanisms were established. And this is something that is a danger in general. I would not say in terms of data spaces or whatever. This is danger of whatever, and in whatever the field. And there is something that has always been there. It's not original. And for those of us like me that already have some gray hair or white hair, if you like, something. That I still remember the days in which we were talking about open networking in front of the proprietary solutions or architectures that were proposing by I guess that is nothing. It's not secret if I named right now what there was back in the 70s and the 80s. And we're talking about IBM and the network architectures of the solutions that were the one-headed solutions provided by Microsoft. Things have not changed. We keep doing or trying to fight very practical and very quick solutions that are supported by giant corporations that try to be in control of everything. And this is something that still is an open challenge, I would say.
Okay, thank you all. I'd like to continue with a question more focused on HEDGE-IoT, or it's actually valid, I think, for R&D projects in general. So how can this collaboration between R&D projects like HEDGE-IoT and standardization bodies be improved? Also thinking into perspectives, contribution to standards, as we already, several of the speakers mentioned, and also the adoption of existing and future standards. So how can this coordination be improved to support the existing standards, and so in definition of standards and also the adoption of those standards? So yeah, open question. So who would like to start?
I can start. So the dream and the objective is that we have projects, research projects, which have pilots, okay? It was not the past, in the case in the past. Now it's systematic that when you grow and you mature, you have pilots, okay? So the pilots, they provide use cases, problems, and sometimes solutions that are important input to standards. So when you have a use case, then when you analyze the use case, you can get to standards, okay? And this is what's going on for data space. We have all those use cases, pilots, We need to put them together, and then the pilots can focus on specific aspects, specific needs, which actually Sebastian has presented, and actually Diego on all the issues that we have to solve. Okay, this is this. Okay, and the second thing is that, and this is a bit unfortunate on the research project, is that they have they end at some point, and we have something we call exploitation. Okay, so exploitation is super important because you need to progress. Okay. And exploitation, standardization is key, okay? So we need, and the message is all the research projects should spend more time to prepare for exploitation, and in preparing so, also anticipate standardization, okay? And of course, the good thing about standardization, it gives them somehow the direction where you can bet somehow that something is ongoing and then you can go, okay? I'm not saying it's perfect, but having the body language of standardization people also give you a sense of direction. Okay, so we need to do this, and we need to explain those things. So the hourglass model, which I've presented, is one page, okay, slide that you can show to everyone, includes all the things that are important for the managers and also for the technical guys. Yeah.
If I may add briefly on this, so I think there is another important issue that we have just we're not in sync with a project that have a limited time life, and also the standardization project that have a different life of time, and this is not in sync, and this is an issue because well, you need to somehow establish a new liaison with a project or whatever from each and every project, but this is a practical issue. I think the more important aspect is that we have people, that we have experts, and that we have their organizations that keep supporting the standardization activities ongoingly across various research projects. So what I wish to say is we need to take care that we get younger and fresh experts from the R&D project. So people need to be educated early to understand how standardization works, to understand how it works, how they can contribute on a continuous level, and also how they could leverage this continuously. I think this is an important aspect, to get more younger experts in the standardization area that are continuously interacting with the bodies, and not only for one project hopping on and off again. That's just too short.
Just want to mention one last thing is that the Commission is aware of that, and they have Standardized CT, which is funding experts, and they have HS Booster, which is actually training young experts. Okay, but maybe we should get to the next stage to scale this up. Okay, so that we really get the reward, the feedback, the reward, the return on investment that we can have.
And we cannot only rely here on public funding. So as much as I like those projects, as I support them, however, it's really a continuous investor from the organizations to bring up new experts. Otherwise, we will not have European experts in the European standardization projects anymore, and not talking about the international ones.
Right.
Yeah. Diego, would you like to add on that?
Not basically because you know, IoT is not our. I mean, you mentioned especially IoT, and I refrain from commenting, but in general, the practical aspects and what I was calling this demonstrative deliverables from the very beginning has been our of our commitments. And this, as I said, it's not only about demonstrating that something can be done, applying standards. That's what is something very important, showing that there are practical cases that makes the that can take advantage of the existing standards on the one hand. On the second hand, and this is something that is very much connected with research activities, whether funded by the European Commission, national bodies, or even not necessarily funded research, and even facilitating the work of startups that want to be better now. These demonstrative deliverables, the idea of having a framework in which you can show and provide feedback on your experience of applying the standards and deciding how standards has to evolve are quite important. I think that this is the same way we were talking about open source before, the engaging early research and practical results, and showing this as another kind of results of the standardization process is something that is extremely important, especially in these days.
Okay, thank you very much. We have some minutes left. Please, if somebody would like to ask a question, please either raise your hand or write it in the chat. Otherwise, yeah, we continue. Yeah, maybe we can, yeah, now tackle a different topic, and which is AI. So we all know AI will replace all our jobs soon, but until that happens, I'd like to talk more about the role of AI in semantic interoperability. So how do you envision the future in semantic interoperability when we apply AI? How will it change what we currently have or currently know? And also, who would like to start?
So I'm working in several standards on AI. I'm the editor of 27091, which is AI privacy protection. But your question is interesting because there is in reality, it raised the issue of how are we going to smoothly integrate AI. Maybe it's never smooth. It's going to be always revolution. Okay, but how do we integrate smoothly AI in our practice and in our standards? Okay, because AI is everywhere. So the picture I showed is actually every single standard can be influenced by AI. Okay, so you have the problem of AI itself as a machinery. Okay, which we need to control and things like that. So, and then we have what it brings to us, okay? And both are important. So what it brings to us is exemplified by this generative AI. So you could have a large language model that is actually telling you how to do better something, okay? And so we are focusing on this racing people building ever-growing, let's say, LLMs to help, okay? So that's the business, because people think this is the business of the future, okay? So yes, we need to have this, but I think, yes, we have to have some understanding of how we're going to integrate this. I'm going to call this an architecture of the ecosystem of AI, okay? And this we need to understand, and it's not well understood, okay? We need to control it. We need to make sure at the end of the day, it's human oversight and not agent oversight. Okay, so we need to, and those, to be frank, standards are not yet tackling that. In SC42 last week, they started touching about that. Okay, and we'll see this in particular in data space, because the agents, the AI agents and the human people, they will be participant to data space. Okay, so I think we have a really good foundation with data space, but the next stage is to see what it is we ensure, so that actually the agent is following the same rules and policies than the organization participating. Yeah.
I fully agree to Antonio's statement. So, Diego, you go first.
No, go ahead. No, please, Sebastian, please.
Okay.
Go.
So, I fully agree. There's just one aspect that I would like to add. So, of course, AI can do a lot of things, and we need human oversight. But there is another aspect that we should not forget. So every time the AI does something for us, it consumes energy. It has a carbon footprint. So maybe it's something that we should really consider also in specific use case. Where does it make sense to get support from AI and do some transformation on the fly? Or when does it make sense to just have a stable environment and agreed set of standard that we work on, to just avoid costly transformation and analysis of data that is unneeded. So this is another aspect that we should consider, that, well, it's cool and I really like it. I'm still a techie. However, it has some other implications beyond just applying cool technology.
Yeah, whether they believe that the AI is something that the important thing about the AI in terms of the application here is about the autonomy of the AI. Something that for the first time is that we are considering technology creations or technology artifacts that we are going to deliver on reality, if you like, and will take will take decisions on their own, making them not necessarily deterministic. I mean, at the basic level, probably they are deterministic, but they are going to behave in a non-deterministic way. For this, I think that what I mentioned before about these concerns about how you establish your identity, how you are able to trace back who was doing what, and on behalf of whom is something that is essential. Essential for keeping control. As I think it was Antonio who was saying that it's not agent supervision. It has to be, at the end, we need to retain this human supervision, even if it is applied only in very seldom, but always that is required is something that we need to have the tools in place for that.
So just want to add about this carbon footprint. Thank you, Sebastian, for telling this. We need to have more reusability properties. Okay, so we cannot just afford to relearn everything from scratch. Okay, so because otherwise we will spend the whole energy of the world to do it. So we need to be able to reuse. So again, it's an architecture thinking of how we create those learnings, those models and things like that, okay? So it starts, by the way, with reusing ontologies. And we have actually, in my company, a person that is doing a PhD on that because we want to foster reuse. But reuse is everywhere, okay? So reuse, you need to reuse models. You have small LLMs, big LLMs. Sometimes a small LLM is just using one part of the knowledge and that's it. And it makes the job, okay? So, and we do not have yet some thinking, discussions, how this can be done properly so that the carbon footprint is then sustainable, okay?
Okay, I know we're already, it's already 1, so we should finish, but I would like to ask one last question. And if this just, I would just need like one sentence as an answer, so it's gonna be difficult. But last question is, looking ahead, like what should be the next priorities for European standardization to strengthen semantic interoperability across sectors?
So I already know because I prepared the answer. So as member of SC41, I'm going to ask to have a liaison with HCTC data, because otherwise we cannot work. We have to work together. We have to align. Okay, this is the most important action for the next 6 months.
So let me say that we need the liaison with the GT41. And that's basically no. It's true that having a clear, define clearly which are the connections and make us evolve in a coordinated way. It would be essential. Definitely, yes.
So I would not go into the same direction. What I'm still missing is really practical governance for all the cool semantic assets that we have. It's still too much scattered and distributed. And I think this is something that standards really need to consider, something like quality of semantic assets. I know ETSI is addressing this at the moment. And this is for me still the most important thing that we need from my perspective now.
So 2 important things.
Okay. Great.
That's easy.
Yeah. So that will be my last question. Yeah, we're already over time. Thank you so much. It was great also to have experts as speakers, and also I think I didn't mention, so Sebastian is the chair of CENELEC ETSI 25, and Diego is the chair of HCTC Data. So it was great to have them both on stage. And also you, Antonio, with all your years and years of experience in both standardization and the projects. I think you're involved in probably every single activity regarding standardization today. So yeah, it was really great to have you. Also, big thank you to my colleagues from HEDGE-IoT who presented and also helped me organize this. So Leo from Trialog and Laura and Cornelis, and also, of course, my colleagues Silvia and Katia from IDSA. Thank you so much. Thank you also the audience for attending. I hope this session was useful for you and also for your projects. Yeah, the recording will be made available. So yeah, that's it from my side. Thank you all, and yeah, see you soon.
Take care.
Thank you.
Thanks all.
Take care.
Bye-bye.
Bye.
Thank you. Bye.
Thanks. See you.
Thanks. Bye-bye.